Before we start with today's video, please make sure that you're also subscribed to the second channel, The Bauer English, because for the future, this will be like the second or third last video we're posting on the main channel, and for the future, every English video will only be posted on the second channel. Thanks for your support and have fun with today's video. Hi and welcome to a new video. Today we will build a mini ITX system inside the Revolt 3 case, which is a new product from HYTE, and HYTE is a sub-brand from iBuyPower. Since you're watching like from international, I don't know, might be watching from the US, then you will be very familiar with the SI iBuyPower, where you can buy pre-built systems with very good quality. And they are now offering also special cases under the brand HYTE. And that's pretty much one of the first products, the Revolt 3. And yeah, we're going to check this out today. Just from the initial feeling when I unpacked this from the box, I already had the feeling that it really feels high quality. It doesn't feel like a cheap product, and it's also not cheap. The case itself comes at $129, and there's also a version with a PSU included, which is what we also have on the desk right here, with a 700 watt SFX PSU built in, and this one is $249. Obviously, depending on where you're from, this might change a little bit, but that's also already not a cheap price for a small system, but it's also not that small. If you compare it, for example, with the Den case, which is about 7 to 8 liters in volume, this one is 18.4 liters in volume. So about 40 centimeters, 25 centimeters, and yeah, I forgot about the third dimension, but yeah, it's a smaller case, but it's not a tiny case. But I'm curious to see how this will perform. And talking about performance, we will first set up all the hardware on the table, do some reference measurements, check out temperatures of CPU and GPU, so we can have some comparisons once we put the hardware inside the system and see how this will affect temperatures. All right.
Seasonic, the heart of your system.
The C590 iGaming Wi-Fi is going to be the board we're using for today's build, which you can see right here. It's also quite impressive, quite interesting design. Very massive thing down there. And that's also where our M.2 drive will be located. The M.2 drive will also be relevant and interesting. Going to use the Seagate Firecuda 510 2TB drive, because we also want to know what the effect will be on the temperature of the M.2 drive once we put it inside the system. So we'll take before and after temperature measurements for comparison reasons. And we also have those Vengeance Pro RGB kits, 3600 C18, just an average memory kit for our build. And of course, 11600K for our testing, and then going to assemble everything to take some temperatures. I first removed this cooling part block of the mainboard, which also has some surface area, at least right here, but it also comes with RGB built in, I think. At least we have some like connection pins right here, which go into the board down there, which is also part of the audio solution. Well, this board is the audio solution, to be more concrete. And yeah, I mean, RGB built in such parts also leads to a slightly higher temperature, but yeah, going to be interesting. And the SSD is already sitting inside the slot. And the memory sticks and the AIO is also present, just have to mount the second fan. As you can see, it's a 280 ROG AIO, obviously. I mean, if you would buy this type of like configuration for this case, I would probably not take this AIO because it's way too expensive, considering that you're not going to see it, right? Because as you can see, everything is like heavily ventilated for like good airflow, I assume. I mean, there's still dust filters and stuff behind, which we're going to take a closer look at soon. But I just want to highlight that the 280 AIO, which I have right here, I'm going to use it because I have it here. And if you're going to buy like a similar configuration, you would probably take a cheaper 280 where, I don't know, you don't need RGB, right? Because you're probably not going to see it. You're also probably not going to see any kind of like LCD displays. But since the case supports 280 AIOs, I also want to see if it works, if it fits. GPU compatibility will be interesting. At least there is already a tested graphics card list. This should also already later be available on HYTE.com. This is how it's going to look mounted inside the case. So they have this list of tested cards. I mean, that's plenty. Most of the cards seem to work out, but there's also a list of incompatible graphics cards. And what we straight can see is that I guess most of them are incompatible because of the height of like 70 millimeters on the ASUS cards and maybe 33.2 centimeters length on the ASRock card. Yeah, not sure what it means for our card. My original plan was to fit this MSI Supremax card 3080 But then it's also 61mm height, which I just checked, like the dimension right here in the center. Worst case, you will have to mount a Founders Edition card. Okay, so it's just right after 10 o'clock in the evening, and I started at like 6 p.m. and thought I should easily be able to run all the thermal testing within this evening and maybe even start assembling the system. And then, I installed Windows, installed all the tools, and then I went to BIOS and did like a normal OC with the 11900K, 5 GHz, 1.39 volt, which is like average, I would say. And then I did a 3D mark, which passed fine, no issues. And then I ran Prime 95, and I had an immediate crash. So I thought, okay, maybe CPU can pass 3D mark, but not Prime 95. So I lowered 100 megahertz on a CPU clock, ran again, immediate crash. Lowered 100 megahertz, ran again, crash after 3 minutes. Lowered again 100 megahertz, ran again, crash again after 3 minutes. Lowered again crash. So at a certain point I was at 4.5 gigahertz with like 1.44 volt, which is absolutely not possible. There is no garbage CPU on this planet that cannot run like 11600K, that cannot run 4.5 at 1.44 volt. That's just not possible. If the CPU can easily run stock, right, it makes no sense. And after a certain time, I thought first that maybe the memory kit is damaged, so I just swapped to a different kit. Basically the same type of kit, but just 4000C19 instead of like 3600C18, but like similar ICs, exactly the same memory kit from Corsair, which also didn't work. So I thought, that's kind of not possible. And then I tried a different version of Prime 95, which was working fine, which is still running right now. And then I figured out that maybe the Prime 95 version was corrupted. So I downloaded it again, and it's still corrupted. So the download, which is offered online on build 30.6, build 3, is corrupted. Whenever I run this, it's immediately crashing, like every single time. And now I downloaded it somewhere else, and it's working fine. I downloaded like 30 point something, like a different build, but this build is running fine. It has been running for, like 15, 20 minutes already. Yeah, that's how you can waste 2.5 hours. Happy that it's running now, so we'll continue testing. Finally, everything worked out as planned. You can see we passed 20 loops in 3D mark, which equals pretty much 20 minutes as well of testing. So at that point, temperatures shouldn't raise anymore. Max CPU temperature was 84 degrees Celsius. We had a continuous load of about 180 watt, which I think is far more than what you would have in any kind of gaming scenario. If we go down to the VRM temperature, you can see a max of 80 degrees Celsius, which is still fine. But also you have to keep in mind that there is a small fan underneath the heatsink, which was spinning at a max of 5,500 RPM, which I think is quite a lot. Luckily, it's still quiet. I couldn't really hear it, so that's at least not that bad. Dim temperature was a max of 67 degrees Celsius, and if we go down to the GPU, peaked out at about 80 degrees Celsius at just 1400 RPM fan speed, which I think is quite low. I'm expecting to see higher RPM rates on the GPU and at the same time also higher CPU temperatures because of the hot air intake, which we will see on the radiator. Just in case the MSI card won't fit, also some reference values for this 3080 Ti Founders Edition. That's a max of 72 degrees Celsius at 1800 RPM. Finally going to start to talk about the case. So I have to lift the case anyway on the table, right? So this comes in handy. There's an integrated handle to lift the case. I'm not sure if it's necessary to have a handle to carry around the system these days, but at least it's perfectly integrated and it feels very high quality. Okay, let's get some outside impressions. Overall, the case is very clean, very consistent. You have this type of hole pattern everywhere. There are bigger holes in the front than on the side or on top. But overall, it's a very consistent design, very sleek, very elegant. Yeah, looks pretty awesome, I have to say. There are also like smaller holes behind it. I'm not sure if you can see it, but it's not like there's a free airflow through those bigger holes, also on the side. Trying to make it visible, but a little bit difficult. But I guess you can see there are tinier holes like inside those bigger ventilation holes, which I think could definitely restrict the airflow. I mean, it's also there to also restrict the dust coming inside the case. But airflow is going to be one of the bigger questions, especially because once you pack everything inside, like the big GPU, the AIO, like you have the tubing, the cables and everything, that will restrict the airflow further. So we'll see what the temperatures will look like afterwards. But overall, it's a very consistent, very harmonious design. Big fan of that. Looks very elegant. Check out the front panel. So there's the start button. We have dual USB Type A, USB Type C, audio jack on the side. And also that's something I noticed right at the start when I unpacked the case, and that's a pretty interesting feature. So you can pull this out, and that's going to be your headphone holder. That's also a very interesting feature. Cool integrated. You can move it back if you don't need it. And there's also the same thing on the other side. So you can freely choose which side you want to put your case on the table. The backside features the same kind of hole pattern which you can see on the left and right side. And right on bottom you have the power connector and also a switch, which we're going to talk about more in a second. If you want to open side or back panels, you just simply pull these off. There are no screws involved. And if you turn it around, you can see those like tinier holes for dust filtering. So initially when I first opened this and just looked at the interior, I straight had to feel like it feels like really high quality. If you just check out, like every edge is deburred, you cannot cut yourself anywhere. Everything feels really stiff. I mean, that's also because it's obviously a tiny case. You don't have such big areas where you could do any kind of bends, but it feels like very solid, which is something I like. Also, there's a HYTE logo on bottom, which is paying attention to tiny details, because at the end, I mean, you will have your cover on top, you're not going to see this logo. So the fact that they printed the logo down there, even though you're not going to see it, it's kind of cool though. All right, so if we turn this around, you can see there's the 700 watt integrated PSU, and there's also an extension cord, and there's also this extension cord going from the PSU to the bottom, and that's what I talked about earlier. So there's this like power switch, which is integrated. I think that's quite cool, because ultimately, if this would be closed and you would have it on your desk, you cannot access this switch unless you open it completely. And it's kind of cool that you have like an additional switch, so you can switch off the PSU or the PC without opening it. If you remove the screws on top and bottom, you can open this like radiator door, I would call it, where you could mount anything from like 120, 140, 240 to 80 radiators. I mean 240 to 80 would make the most sense, I guess. On top there is also a hard drive bay, so like from this side next to the PSU you could also mount your 3.5 inch HDD. In the back there would be sufficient space for a 2.5 inch SSD. And as you can see, that's also something more special about this case, is that all the connectors will exit the case to the bottom. So like the display port connection, everything, IO connection will be from the bottom, which, I mean, it's going to make it clean on your desk, but also not that easy to access everything. But yeah, we will see how this works out. In the back is the tray for the mini ITX mainboard, and I mean, there's not much else to say about this case because it's a tiny case, doesn't have that many features. They stated in the review guide that if you want to mount a very, very big GPU, you might have to open the top. We will see if it works out with the MSI GPU or not. I will not use any HDDs or SSDs, like 2.5 inch SSDs. So I decided to remove the SATA cable and Molex cable because it's also a modular PSU. That's quite nice. What I didn't like that much is the fact that, the HDD cage right here is also at the same time the PSU cage, which means that you cannot remove this part right here. I'm not sure how many people in this type of a system would use a 3.5 inch HDD. I guess it's more likely to use a 2.5 inch SSD. And I think it would have been a bit smarter to make this also modular, like the HDD cage. Maybe make this removable so you have more space for cable management and also for airflow. And instead also, like right underneath, have like additional 2.5 inch mounting areas for like a 2.5 inch SSD. I think that would have been better, like space-wise. Obviously, you could still put a 2.5 inch SSD in here with like an adapter. That would always work, but yeah, that's something I would have changed. Okay, now I realize what the problem is with the top part, that yeah, this won't fit in. But maybe if we remove the top, let's check. With 4 screws, you can remove the top cover and then access this. I actually thought it would somehow be possible to remove this part right here. Seems like this is fixed through a rivet. Not sure if that's going to be possible. At least we discovered something new. So there's a frame right here where you can mount additional 280mm fans, but also like slim ones. I have 80mm fans, but I think they might be too high. I have to check. And also have to check if there's a way to squeeze the card in. I decided to remove the front I/O shield of the card, which allowed to just move the card through the top. But then right now the card is like colliding with this part of the I/O shield of the board. I'm missing like 2mm to move the card to this direction because it's also colliding right here. I guess officially this would be like an incompatible card, but I will try to tweak it further. Maybe there's a way to, I don't know, like unmount the mainboard, move it a bit to the back and see if I can squeeze it in somehow. Yep, as you can see, the card is sitting inside the case. And like by 1mm. It couldn't be any millimeter longer. As you can see, it just ends directly with the case. It's enough that we can still put the cover on top, so that's fine. The key to fit the card in, I mean, it was more complex. So first of all, I had to remove the mainboard. Then I moved the card back a little bit and added the I/O slot to the card, mounted it back to the card. Then I put in the motherboard again, but I left away the screw right here and only mounted it with this screw in this corner, but didn't really fix it, like didn't really tighten it that much. In this regard, I could pull out the board a tiny bit, like 1 or 2mm, to make sure that doesn't collide right here. Moved the card inside the slot, added both screws, added the screws right here. So everything is, there's no way this can move like any millimeter. But officially this card is definitely incompatible, but it works. She is just inspecting the case as well, and she told me that I should maybe get some fan grills because, yeah, fan grills. Things that I think, didn't use in like 15 years. But the thing is, I just tried to mount the AIO, like fans mounting inwards. That's also the recommended way from HYTE. But the thing is, you can see there is not that much space, right? I mean, the radiator with the fans will sit somewhere here, which means that we have like 5-6 centimeters of space right here, and there will also be the pump head. And then we will have the pump head and all the tubing, and the tubing will very likely be like touching... Sheik is dropping stuff again, thanks. The tubes will very likely touch the fans. So we have to protect the fans, and I think fan grills are the easiest way to do that. Okay, so in the end, that was actually easier than expected. So once I had the radiator installed and also the fan grills especially installed, I could just flip it in, and that worked out nicely. So one thing that I'm missing kind of, I mean, there's this plate. This plate would go here. And I think it's also to cover the cables in a term that if the cables would stand out, they could maybe like press off the side panel. But in my case, literally, the cables should be fine and should not move the panel to the side. So I'm trying to leave it away because I think we're going to block the airflow of this part if we're going to mount this thing. And the rest and the internals actually also looks okay. There is sufficient amount of space for airflow, both for the bottom fan and also for the top fan, especially because the HDD is not installed. If the HDD would be installed, yeah, there would not be that much ventilation for the top fan. That wouldn't really make that much sense, I guess. And again, it would be nice if you could just remove this bracket right here. And you can also see that the memory kit doesn't look that great. I mean, it's getting squeezed down from top and bottom. From the bottom through the tubes of the AIO and from the top with the PSU cabling. Yeah. And talking about RGB of the memory kit, I mean, I wouldn't use any kind of RGB kit, just use like a low profile kit, and then you won't have this kind of issue that you're seeing right here. And for the AIO, just use fans without RGB, because as you can see, it's not even connected in my case, because why? You wouldn't see it, so I just left it away. It's less cable that are hanging just in the middle, and I think it's going to be okay. The back looks cool. There would still be enough space to mount the SSDs if you wanted to, so space-wise, I think the design is sufficient. Very curious how this thing is going to perform now thermally. I just started testing and had something extremely weird. So I started Prime 95 with 10 threads out of 12 because 2 threads I reserved for the 3D Mark, otherwise there wouldn't be enough computing power left to utilize the GPU fully. And then, I had this window selected, the 3D Mark window selected, and I checked in GPU-Z the clocks and power draw and thought like, why is this so low? It was like 1200, 1300 megahertz. It's now at 1500, but just check the power draw. It's 150 watt now if the benchmark itself is selected. And if I now select GPU-Z, it immediately increases to like 300 watt and almost 2 gigahertz. I don't get it. That is super weird. Time to evaluate the temperatures. The CPU is getting toasty. 96 degrees Celsius, that is absolutely on the edge of throttling, but as you can see in the average clock and also in the minimum clock, it did not throttle, which is good, but there is not much more headroom. Again, it's about 180 watt continuous load. It's about 5 watt more, probably because of the higher temperature, because that also equals higher power consumption if the settings are the same. So same clock, same voltage, higher temperature equals higher power draw. And then if we check out the VRM of the mainboard, and that's also kind of expected because now we have some airflow. Previously we didn't have any kind of airflow. So we're seeing better temperatures by about 5 degrees Celsius. At the same time, 2000 RPM less on the VRM fan. Dim temperature is improved by a few degrees Celsius. Going to check out that in a second. And the GPU is about 100 RPM less at the same temperature. I guess that's because the AIO will help dissipating the warm air out of the case. And looking at the SSD, it's also 6 degrees colder than previously without any kind of airflow. And the speed of the SSD is also as expected, so it didn't throttle, everything in line. I just checked the temperature data and compared it to the open test bench results. And the CPU temperature didn't look that nice. We will check the details in a second. And then I thought, okay, I'm going to change the fans on the radiator because the configuration right now is pretty much what they recommended in the review guide, because they also did some internal testing, gave some good guidance, which is pretty nice that they did such a big amount of testing. That's what you saw also with the GPU compatibility list. But then I thought we used such a big GPU that basically the entire front will be our intake for the GPU. And it's also sitting so close to the side panels that also the side panels will kind of act like exhausts. So I decided to do, well, first of all, I did gaming benchmarks of this configuration, so we can also check that. And then we will now swap the fans so they are also doing cold air intake and see what happens. We will first compare the test results of the open test bench versus our first fan configuration, which was when the fans are working basically as exhaust on the radiator. So you can see the Revolt 3 will cause the CPU to be 12 degrees warmer on the CPU and 400 RPM more on the fans on the radiator if it's inside the case versus the open test bench. Whereas the VRM is a little bit cooler because previously there was no airflow, and also the GPU is definitely colder, 200 RPM less while maintaining about the same temperature. SSD also less, about 5 degrees, and same goes for the memory. But then I thought, what about gaming? Because in the gaming scenario, the CPU load will definitely be lower than doing an artificial Prime 95 run. And also the GPU load, the GPU will be the limit typically in your gaming performance. That's why the focus should be on your GPU cooling. And that's also what we can see if we move to gaming load in Remnant from the ashes. We can see a drop of 23 degrees Celsius on CPU temperature while also running a lower RPM of 400 RPM less on the radiator. Just shows how much less the CPU is loaded in a gaming scenario. Whereas we can see there's definitely a higher load on the GPU. It's basically the same as running open test bench, 79 degrees Celsius and 1400 RPM on the GPU. But also interesting that we could see the highest peak in dim temperature in the gaming scenario, because it seems like the memory was more utilized in the gaming load than in Prime 95 or 3D Mark load. The last comparison is Remnant from the ashes exhaust versus intake, basically flipped the fans on the radiator. And as expected, because it's like a cold air intake, that's the best possible scenario for the CPU. We could see a 4 degrees Celsius drop in temperature on the CPU. while we could see basically an increase on almost everything else. VRM increased by 3 degrees while also increasing 1000 RPM on the VRM fan. But the most important increase was on the GPU, because we could see 2 degrees higher on the GPU, which is not that like a drastic increase, but we could see an increase from 1400 to 1700 RPM on the GPU. And you can definitely hear that. 300 RPM more on the GPU is something you can hear. So as conclusion, the best configuration is that you use your fans. If it's a PC for gaming load mainly, then you would use the fans in exhaust, because then the fans will help to like dissipate some additional of the hot air from the GPU through the fan as exhaust, and that gives you the best overall system temperatures. In gaming, the CPU will not be that much affected. If you're using this for like computing load on the CPU, then maybe intake would be better. Time to draw a conclusion. Overall, build quality, starting with that, is perfect. There's nothing I would complain about, like all the screws were perfect, all the edges, painting, just the feel it has. It's a very high quality case. Absolutely like it from that perspective. There are certain things you have to think about though. First of all, let's start with the USB Type-C, which is in front right here. But it's not an internal USB Type-C, which is kind of weird because you're just connecting it to the I/O of the mainboard. I'm not sure why they did that. I mean, there is enough room that you can route it through internally, and then you could just use an USB Type-C extension from your mainboard and have one more connector. So not really sure why they did that. I wish they would make the HDD case swappable or removable, because depending on your cooling configuration, it might give you better cooling results because the top fan would be able to breathe easier, I guess. So not everybody is going to use a 3.5-inch HDD. I guess you can kind of neglect that. Overall, we have to talk about the cooling concept though. So if you look at the case just from like the first perspective, the first image you get from the case, it's like, it looks like an airflow case, right? Like a ton of holes everywhere. Everywhere just made out of holes. And you think the air will just flow right through and you will have the perfect temperatures. Temperatures are good overall, but there's some things you have to consider. For example, the front will just act as a GPU intake. But it's just the part right here. I would say 2/3 from the left are GPU intake. But like the first, I would say 3 holes from the right, the first 3 rows, there's basically a ton of room behind that, and that goes underneath the GPU. And that's where a lot of hot air is actually coming out, because that's coming out from the back of the GPU, like coming around here and just exiting here. And at the same time, I mean, if that's the intake and that's the exhaust, the intake will definitely also intake some of the hot air. And that's the same you also have on the entire, like the side which is facing me right now, where you have the radiator for CPU cooling and also your GPU. It feels like 2/3 are the intake for the radiator and 1/3 is like exhaust for the GPU. That's why this also should be exhaust for the CPU radiator. Otherwise, like 50% of your hot air from the GPU, which is coming out, will straight be intaken again on the CPU radiator. And yeah, that's something you should definitely consider. And in the configuration where your radiator is acting as an exhaust, then you will only have like hot air coming out on this side, which is facing me. You will have an intake here, a little bit of hot air coming out of here, a little bit of hot air coming out here, and this side will be intake, and the entire back will be intake. And the top is also mixed. Like the front part is like exhaust and the back is like intake. So there's a lot of mixed on the cooling, and that's definitely also affecting temperatures. But in a way, I guess, which is still fine. I mean, you saw the temperatures. It's an overclocked 11th gen CPU, 180 watt continuous power and a 3080, and it worked fine. CPU temperature, depending on your scenario, was not the best, but if you use it for gaming, I guess it's okay. Overall, it's a great case, I think, but it's also fairly expensive. Considering the build quality, I would consider it's also a fair price of about $130 without PSU and $250 with PSU. I would consider it a fair price, but it's not cheap. But overall, it's definitely a good case. All right, thanks for tuning in. It's just after midnight. Sheep is already asleep. Did I just say sheep? Sheik is already asleep. Oops. Yeah, and we still have to cut the video to make sure it's online tomorrow. Thanks for tuning in. See you next time. Bye-bye.